The last thing I want to mention in this section is if a derivative is a function itself, then we can find the derivative of that derivative. So we can get something called the second derivative. The derivative of a function is f prime. I can then take its derivative. And so I get 2 primes. So we actually write it as f double prime like this. If you want to use Leibniz's notation, then you have dy dx. You're then going to take the derivative of that with respect to x. So we have d dx of dy dx. There's 2 d's, so that's d squared. There's 2 dx's, so that's dx squared. So we can talk about finding the second derivative because we have this first derivative, and the first derivative of the function. So let's go ahead and do an example of finding the second derivative. That means first to find the second derivative, I need to first find the first derivative. So I first need to know what is f prime. So f prime, and I think I might have done this already, but we're going to do it again. This would be the limit as h goes to 0 of f of x plus h minus f of x all over h. This is the limit as h goes to 0. My function is something to the fourth minus 2 times something. My function again is something to the fourth minus 2 times something all over h. Well, in the first case, my something is x plus h. So I put x plus h, x plus h. And my second something is x. And then I just have to multiply this all out. So x plus h to the fourth would be x to the fourth plus something, we don't know what that is just yet, but something x cubed h plus something x squared h squared plus something x h cubed plus something h to the fourth. Then we have minus 2x minus 2h, then minus x to the fourth and plus 2x all over h. Using Pascal's triangle, we can fill in these somethings. Using Pascal's triangle, this is a 1, 4, 6, 4, 1. Okay, so we have the limit as h goes to 0 of x to the fourth. Now there's an x to the fourth here, there's a minus x to the fourth here. So those actually will cancel. We then have a 4x cubed h plus a 6x squared h squared plus a 4x h cubed plus an h to the fourth. Then we have this minus 2x, but it also has a minus 2x. So those minus 2x's cancel. And then we still have this minus 2h all over h. Then this is the limit as h goes to 0. Notice that every single term in the numerator has an h in it. So you can factor an h out and cancel the h in the bottom. So that'll give you 4x cubed plus 6x squared h plus 4x h squared plus h cubed minus 2. Now calculus, finally, when you let h go to 0, remember 4x cubed does not have an h in it, so it doesn't actually get affected by h going to 0. So it's considered, in this limit, it's considered a constant, so it's 4x cubed. The 6x squared h, you can put a 0 in for h, but 0 times anything is 0, so this goes away. 4x h squared, again put 0 in for h, this term will go away. H cubed, put 0 in for h, this term will go away. And then minus 2 is a constant. So there's my first derivative. But I want the second derivative. So to find the second derivative, I'm going to take the derivative of this first derivative. And so I'm doing the limit as h goes to 0 of f prime of x plus h minus f prime of x all over h. So notice there's a prime here, and there's a prime here and here. So this would be the limit as h goes to 0 of my function. My derivative function is 4 times something cubed minus 2. My derivative function again is 4 times something cubed minus 2, all over h. So in this case, my something that I'm putting in here is x plus h. I have nowhere else to put it. In this something, it's just x. So I'm going to plug those in. And then I just have to multiply this all out and collect like terms. So we have 4 times, let's multiply this out. This is going to be x cubed plus something x squared h plus something x h squared plus something h cubed minus 2. And this is all times 4. And then the minus 2 is not. Then we're going to have minus 4x cubed plus 2 in this after the negative sign. All over h. Multiply the 4 through, but we have to fill in these somethings. So using Pascal's triangle, this would be 1, 3, 3, 1. So we have the limit as h goes to 0 of 4x cubed plus 12x squared h plus 12x h squared plus 4h cubed minus 2 minus 4x cubed plus 2 all over h. All right, we're almost done. This is the limit as h goes to 0. Collect your like terms. See what cancels. The 4x cubed and the 4x cubed will cancel. 2 and the 2 will cancel. So you're going to end up with 12x squared h plus 12x h squared plus 4h cubed all over h. Again, all these terms in the numerator have an h. We can pull the h's out and cancel the one in the bottom. We get the limit as h goes to 0 of 12x squared plus 12xh plus 4h squared. Again, letting h go to 0, 12x squared doesn't depend on h, so it's considered a constant in this limit. So it's just 12x squared. 12xh, h is going to 0, so this term goes to 0. 4h squared, h is going to 0, so this term is going to 0. And your second derivative is 12x squared. F double prime is the rate of change of the rate of change. That's what the second derivative means. So you can do the rate of change of the rate of change and see what happens with that. We can also do a third derivative. You put 3 bars there, that would be the third derivative. The fourth derivative gets a little cumbersome counting how many bars there are, so we just start putting a little 4 inside parentheses. The fifth derivative would have a 5 up there. The sixth, the nth derivative would have a little n up there. So you can do that. Now let's talk about what do these mean. And it depends on what you're dealing with. So if s is the position function, then the first derivative, s prime, is v of t, is the velocity function. If you take the derivative of velocity, the rate of change of velocity is acceleration. So we use that a of t, but it's v prime of t. It happens to be the second derivative of s prime, of s. So that gives you the acceleration. So it means something to talk about position, velocity, acceleration. We can actually do the derivative of acceleration, and it actually is called the jerk. So if you've ever been in a car and somebody steps on the gas really fast and you jerk forward, that's the rate of change of your acceleration really fast. After jerk, after the third derivative, it really doesn't mean much. Conceptual-wise, mathematicians like derivatives because we can keep going forever. Physicists would probably stop at the second or third derivative. So, by the way, you can use the Leibniz's notation also. Let's just mention that. If you have the derivative of the derivative, that would be the second derivative with respect to x. If you take the derivative of the second derivative, that would be d cubed y dx cubed. So you just put in a power that tells you what derivative you want. So let's do one more thing. Let's find the velocity and acceleration of this position. So remember, velocity is the derivative of position. So it's a limit as h goes to 0 of f of t plus h, because we're dealing with time, minus f of t all over h. So that's the limit as h goes to 0 of, and we're not using s, we're using f, we're using s actually. So let's go ahead and change it to an s, just to make life a little bit nicer for you. So we have our function is 3 times something squared plus 2. So this is the first time we see it. Then we see our function again, and it's 3 times something squared plus 2. That's the second time we saw our function, all over h. That will equal, the limit as h goes to 0. Let's fill in the somethings. So in the first something, it's t plus h. The second something is just t. So now we're going to go ahead and multiply everything out. This would be 3 times t squared plus 2t h plus h squared plus 2. Then minus 3t squared minus 2 all over h. Take the 3 through. 3t squared plus 6th plus 3h squared plus 2 minus 3t squared minus 2 all over h. You could have canceled before, but I just prefer to not. So now my 3t squareds cancel, my 2's cancel. So I end up with the limit as h goes to 0 of 6th plus 3h squared all over h. I notice that both terms in the numerator have an h in it, so the h's can cancel, and I get the limit as h goes to 0 of 6t plus 3h. When I let h go to 0, this is 6t. All right, so I'm going to get back to my recording. I'm going to finish this recording. I'm almost done. Abby called. I wanted to find out why she called, and then I'm going to finish this recording, and I'll be done with this one. I have one more to do. Huh? Yeah, she needs me to take care of her cat, and she needs me to take care of Michelle's cat. So I need to write Michelle, in fact, to tell her that one.